Hi, I've got a very interesting 3D image problem from class 12 CBSE. This is very interesting and one of my favorite. Let's quickly see how to solve this question. So I have the question here. Find the image of the point 1, 6, 3 on the line. So this is the basics of the question. And you will have some additions followed in this question, like write the equation of the line so far, and also find the length of segment joining the point and its image. All these are going to be very simple additions, one or two steps more after we find what the image is. So now let's quickly understand what the question is, how the diagram will look like, and how are we going to solve this. Have a look at this. This is the point P 1, 6, 3, and the line AB whose equation is given. And we are going to find the image of the point P, which I have marked it as M. I'm sorry, Q. And M is the midpoint or the point through which the line PQ crosses AB. And what is the inference that you can make out from this question? We know that image lies exactly the same distance above the line. It has to be at the same distance below the line. So PM is equal to MQ is the first inference that you could make out from this question. And it will definitely be at right angle to the line, or we call it as a parallel. So it makes 90 degrees. So we will, in short, call it as a perpendicular bisector. So PM is equal to MQ, and the angle made is 90 degrees. So these two are going to be of great help in solving this problem. Now, what we do first initially is that now let's equate this to lambda, and we will find any point on the line AB. So this will be x is equal to 1 into lambda, y is equal to 2 lambda plus 1, and z is equal to 3 lambda plus 2. So you have to write before you do this procedure, you will just have to write any point on the line AB. This is the formula. And we know that PM is perpendicular to AB. So we can go with the perpendicularity condition in the chapter 3D, which is A1, A2, B1, B2 plus C1, C2 is equal to 0. Or in short, we call it as sum of the product of their DRs is equal to 0 is the condition for perpendicularity. So dr of the line AB is here. Before that, you verify whether the line is in the general form. It has to be x minus x1 by 8. So this is the dr of the line 1, 2, 3. So now we have to find the dr of the line PM, so that we will multiply the product of the drs and equate it to 0, wherein we will find out what is lambda. So now we will find out what is dr of the line PM. Okay, so m's coordinate as of now is lambda, 2 lambda plus 1, comma 3 lambda plus 2. And we know that dr of a line where 2 points is given is x minus x1, comma y minus y1, comma z minus z. So the dr of line PM will be this lambda minus 1, 2 lambda plus 1 minus 6, which is y1 minus y2, 3 lambda plus 2 minus 3, which is z1 minus z2. So dr of the line PM's dr is nothing but lambda minus 1, comma 2 lambda plus 1 minus 6, which is y2 minus y1, comma 3 lambda plus 2 minus 3, which is z2 minus z1. So we'll simplify this. This is lambda minus 1, comma 2 lambda minus 5, comma 3 lambda minus 1. In some books, the lambda instead of lambda, we might have used k or t. That's fine. Anything it can be used. Now we got the dr of the line PM. We have dr of the line AB. So now we're going to calculate lambda by the condition for perpendicularity. So this is your A1, this is your A2. So A1 into A2 plus B1 into B2, B1 into B2 plus C1 into C2, which is 3 into 3 lambda minus 1 is equal to 0, condition for perpendicularity. Now let's find out lambda from this. Lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 is equal to 0. So on solving this, you get 14 lambda is equal to 14, which implies lambda is 1. In most of the case, lambda is a perfect whole number, and it can be some weight number also. Just you have to verify if your calculation is right. So lambda is 1. So now what do? You get coordinates of the point M if you replace lambda by 1 here. So the point M will be 1 comma 2 into 1 plus 1, which is 3, 3 into 1 plus 2, which is 5. The coordinates of point M is 1 comma 3 comma 5. How did we get that? Replace lambda by 1, which we just found. Now, the point M, as I told, is the midpoint of the points P and Q. Therefore, you can find the image, which is the point Q, by using midpoint formula. So you will use x1 plus x2 by 2 is 1. So we'll put that here. X1 plus x2 by 2 is equal to 1, which will give us x is equal to 1. We cross multiply and subtract 1 from this. Similarly, y1 plus y2 by 2 is equal to 3. So we get y1 plus y2 by 2 is equal to 3. So y is 0. And the last one, z1 plus z2 by 2 is equal to 5. z1 plus z2 by 2 is equal to 5. So z is going to be 7. Z is going to be 7. So the coordinates of the image is 1 comma 0 comma 7. All right. So this is the question. The first part of the question is over. Finding the image of the point P. Considering AB as a plane mirror, the image of the point is 1 comma 0 comma 7. Now, do you have any difficulty in finding out the equation of this line? You can solve that using 2-point formula. Do you have any problem finding out the distance of this or distance of this? Anything of this sort can be sorted out using our known formula, distance formula from class 10 coordinate geometry, or you can use 2-point formula to get the equation when 2 coordinates are given. So that's it with this question. Go through this repeated times. This is very important and interesting question. We can solve this if we just practice 1 or 2 times. See you also in another video. Practice well. All the very best.